Hey everyone, and welcome. Today we're tackling a really interesting problem called minimum number of people to teach. It's about a social network, languages, and finding the most efficient way to help people communicate. Let's break it down together. Alright, here's the full problem description. The core idea is that we have a group of users, and some of them are friends. Two friends can only talk if they share at least one common language. Our goal is to pick one single language and teach it to the fewest number of people possible, so that every pair of friends can communicate. So let's simplify that. Imagine you're a language teacher for this social network. You see some pairs of friends who can't talk to each other because they don't have a language in common. You're given a budget to teach only one language of your choice. To be as efficient as possible, you want to teach this language to the absolute minimum number of people to solve all of these communication problems. The problem gives us three key pieces of information. First, an integer n, which is the total count of all available languages. Second, a list of lists called languages. The entry at index I in this list tells us which languages person I knows. And third, a list called friendships, which simply contains pairs of users who are friends. Let's trace an example to make this concrete. We have two available languages, 1 and 2. User 1 knows language 1, user 2 knows language 2, and user 3 knows both 1 and 2. Now, let's check the friendships. First, user 1 and user 2. User 1 has language 1, user 2 has language 2. They don't have any in common, so this is a problem pair. They can't communicate. Next, user 1 and user 3. User 1 knows language 1, and user 3 also knows language 1. Perfect. They can communicate. Finally, user 2 and user 3. User 2 knows language 2, and user 3 also knows language 2. They can communicate as well. So the only problem in this entire network is between user 1 and user 2. Okay, so how do we fix this single problem between user 1 and user 2? We have to pick one language to teach. Let's say we choose language 2 as our universal language. User 2 already knows it, so we don't have to teach them. We only need to teach language 2 to user 1. That costs us one person. What if we chose language 1 instead? Well, user 1 already knows it, so we'd only have to teach user 2 language 1. That also costs one person. In either case, the minimum number of people we need to teach is 1. This leads us to a really solid greedy strategy. Instead of looking at everyone, let's first just identify who actually needs help. We can build a list of every single person who is part of at least one friendship that can't communicate. This is our problem group. Now we have to pick one language to teach everyone in this group. Which one should it be? Well, the smartest choice is the language that the most people in our problem group already know. Why? Because if they already know it, we don't have to spend resources teaching them. So, the total number of people we have to teach is simply the total size of our problem group, minus the number of people in that group who are already covered by our best language choice. Alright, here's the full Python code that implements this greedy strategy. It might look like a few moving parts, but it follows our logic exactly. Don't worry, we're about to break it down step by step. First things first, we create a set, which we'll call CKLDUSENCON4, cannot communicate, PORTC. A set is perfect here because it automatically prevents duplicates. We then loop through every single friendship. For each pair of friends, U and V, we check if they can communicate. A quick way to do this is to put one person's languages into a temporary set, and then see if any of the second person's languages are in that set. If we finish checking and find no common language, we know this is a problem pair. So we add both users from this friendship into our CNCon set. The -1 is just to switch from the problem's 1-based user IDs to Python 0-based list indices. First, a quick check. If our CNCon set is empty, it means everyone can already communicate with their friends, so we need to teach 0 people. We can just return 0. Otherwise, we move to the next step, finding the most popular language. We create a list called count, with one slot for each language, all initialized to 0. Then, we loop through every person in our CNCon set. For each person, we look at the languages they already know. For each language they speak, we go to our count list and increment the counter for that specific language. After that loop finishes, our count list tells us exactly how many people from our problem group speak each language. Now we just need to find the highest value in that list. We can call it max count, bichalibishes. This number represents the biggest group of people we can cover for free by picking the most popular language. The final answer is the total number of people in our problem group, which is the length of the CNCon set, minus this max count. And that gives us the minimum number of people we have to teach. So how efficient is this approach? For time complexity, we have a few parts. The first loop goes through all the friendships, and for each one it checks their languages. Let's say F is the number of friendships, and L is the max languages a user knows. This step is roughly proportional to F times L. The second loop goes through the problem users and their languages. So the total time is mainly driven by the number of friendships and the languages people speak. For space, we need a set to store the problem users, which can be at most all users, and a list to store the language counts. This gives us a space complexity of O of U plus N, where U is the total number of users, and N is the total number of languages. So to wrap it all up, the core idea here is really powerful. First, you narrow down the scope of the problem. Don't worry about everyone, just find the specific people who are part of a communication breakdown. Once you have that group, a greedy strategy works perfectly. Pick the language that helps the most people for free. The final answer is just the total number of people who need help, minus the number of people your best language choice already covers. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the Playlist tab and find a playlist that fits your goals. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. This channel doesn't make any money from sponsorships or ads yet, so if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.